So this afternoon I'm going to show you how to use Cyber-Physiology to teach cardiovascular physiology. I'm going to start by showing you a bit about how the program works so I can show you what we can do and what I'm going to do in the next little bit. The program consists of text material so that you can go through any of the topics that we have talked about or will talk about and learn about that text material. There is a series of exercises that cover the same material, and I'll show you more about what those consist of in a bit. There are quizzes to test your knowledge of the material and show you perhaps what you need to go back and look at again. But the heart of Cyber-Physiology is really in the viewers. And I'm going to show you a lot of displays like this. So for example, on the x-axis is time here in a 10-second scale, and on the y-axis with the units here is millimeters of mercury, and what you're seeing is the aortic blood pressure as if there were a needle or a catheter within the aorta to measure and display this pressure. So I'm going to show you, creating a numeric panel, the kinds of data that we can display, either as numerical values or waveforms or loops or other things that I'll show you shortly. Here in this column you'll see all of the systems in which there are parameters, and then within those systems here is the list of parameters, and it's quite a large list of things that are modeled within Cyber-Physiology that can be displayed. For example, that you wanted to teach about the cardiovascular system and you were interested in showing, for example, the cardiac output. I could select the cardiac output to display. It makes it easy for me to just pick parameters that I want to show you, and then they're displayed. And they're displayed in terms of what's being calculated by the simulation at the moment. So you'll notice that cardiac output at 5.48 liters per minute. If you watch that for a while, you'll see it changes to 5.47 and 5.46. And it does that because it's quite real and moving and living and breathing in the background. So when the heart beats, the pressure suddenly rises, as you see right there, and then falls to a diastolic value that's much lower. I can show curves. For example, if you wanted, for example, to focus on a certain aspect of that, I can change the scale. Now, instead of 0 to 200, it's a scale of 0 to 100, so that I can focus my attention more on the change in the curve over that pressure range. I'm going to later on show you one of the trends that I like to display when showing the interactivity of systems, and put the urine output into this display. And then I'll set it in a range that makes sense. So 100 milliliters per hour. And now you can see what's happening to urine output as a function of time. Now, displaying these things is nice, but perturbing them is how I teach with this product. So, for example, if I were to go to one of my tools, and now if you look in the bottom left-hand panel, you'll see that I have access to a collection of tools. One of those tools is blood withdrawal. You can all imagine what's going to happen when I start to withdraw blood. You see an aortic pressure displayed here. You can see a cardiac output, a heart rate, and a urine output. And if I then start to withdraw the blood, you can imagine what's going to happen. Because I think we all know that pretty soon the blood pressure is going to fall. And you can actually see that happening. If you see where the systolic pressure is, as the new line comes around, the systolic blood pressure is falling. The kidneys, of course, have figured that out by now, and already the urine output is beginning to fall too. The cardiac output, if you like numerical values, started somewhere around 5.4 something. It's now down to 5.2 something and will continue to fall. So I'm going to perturb the physiology and ask you to predict and see what's going to happen as I do that, because that's really how I teach using Cyber-Physiology, is I make a change, ask you to think about what that change is going to cause, and then we're going to see what the simulation does. Our patient has gotten pretty sick while we've been going through this simulation. You'll notice that the blood pressure has fallen to critically low values, and the baroreceptors are going to detect that. Right? The baroreceptors that sense the blood pressure and tell the cardiovascular system to respond. And so while I've been talking, the heart rate, and if you look down here in this data viewer, the heart rate, which started at 70 or 68, somewhere around there, is now up to 190 and rising. The urine output has fallen off to almost nothing, so low that it's now off my screen. And although we haven't focused much on the LVEDV, the left ventricular end diastolic volume, what that means is how full the heart is at the end of its filling period. So it's right now 19 milliliters. That's not very much. It started at just about 115 milliliters. That would be a normal value. So this heart is an empty heart. It's an empty heart because I've taken 2 liters of blood out of the poor patient. Okay, so that's what the program can do. That's the different ways I can display information. I can show you waveforms that move before us. I can show you data output if we want to focus on numbers. I can show you trends so that we can see what's happening to something over time. What I'm going to do now is start over and walk through a couple of typical scenarios. I'm going to load a state that I saved earlier with viewers that I've created earlier. And that includes a blood pressure here, which is the femoral artery pressure here in a waveform display. Then I have some data displays down below that include the values for the arterial pressure, the systolic value, the highest value of the pressure here, the diastolic pressure, the lowest. And I've also shown the pulse pressure, which is simply the numerical difference between the systolic and the diastolic blood pressures. I have the ability now to change the compliance of the aorta. That means to stiffen the aorta, and that's something that I've taught the same physiology using animal laboratories, but there are some things that in the animal or the patient you simply can't change, you can't control. One of them is the aortic compliance. Yet it's an important value. It's something I talk about in the intensive care unit when I teach, because it's one of the 2 things that explains the pulse pressure. The other is the stroke volume of the heart. And with this simple display showing you the blood pressure and the pulse pressure, if I change the aortic compliance, we can talk about what that will do to the pulse pressure. And I'll ask you to predict in advance what it can do to the pulse pressure. Before